So here we're going to talk about what a complex conjugate is. Now, so the best way to look at it is with it just a simple, just with an example to start off with. Now normally we write complex numbers as z. So z is equal to, if z is equal to a plus bi. Now that's just some complex number called z. Now the complex conjugate of z, and it's written as, you put in z as we had before, but what you really important, you put in a line above it. That line denotes that it's the complex conjugate, and this is equal to a and bi. The a stays exactly the same, and the big difference here is that the complex part changes sign. So if z was equal to a plus bi, the complex conjugate of z, all you do is change the sign of the imaginary part. Now this seems quite easy, I suppose, but I just want to show you how this works in action. So I'm going to do a quick example. Now if I have z and it's equal to minus 2 plus 3i. The complex conjugate, so the example will be, I'll write it in, find z times the complex conjugate of z. So now if z is equal to minus 2 plus 3i. Well, first off, we'll find out what the complex conjugate is. Now, if we know z is minus 2 plus 3i, the complex conjugate is just minus 2 minus 3i. You change this sign here. Now, something happens when you multiply a number by a complex number by its complex conjugate, and that's the real reason why we're doing these. So I'll start this sum here. We've got minus 2 plus 3i times minus 2 minus 3i. So, splitting this up, I'll write the second bracket out twice. Minus 2 minus 3i. Minus 2 minus 3i. Writing in the minus 2 there. And we've got a plus 3i here. So, minus 2 times minus 2 gives me plus 4. Minus 2 times minus 3i, you think sign, number, then letters. Minus times a minus gives me a plus. 2 by 3 gives me 6. And I. There's no other I. Similarly for the 3i times the minus 2 here. First thing you think about is the sign. So it's a minus times a plus. So the sign is going to be definitely minus. You've got a 3 times a 2. 6 and you've I. So you're thinking sign, number, then letter. And then the final bit here is the plus 3i times minus 3i. So the sign is going to be minus because the minus times a plus gives us a minus. 3 by 3 gives us 9, and I by I gives us I squared. I should have equals to signs there. So this is z times z conjugate. So we've got plus 4, plus 6i minus 6i is just 0, plus 0, and we've got minus 9 times minus 1. I squared is minus 1. So we're left with plus 4 plus 9, which is equal to 13. So, and this is just a little point I'll just pull over to the side here. When you multiply a complex number by its complex conjugate, you get a real number. What that means is you end up with a number without an imaginary part. Now, there's one small link I just want to note here. It's kind of related to if you have a plus b times a minus b, the difference of two squares, you get a squared minus b squared. And I'm just going to put that there to note.